Welcome to another video. Today we're learning dimensional analysis. This is the method chemists use to convert between units in a clean, logical way. And you'll find that this is one of the most important skills in the entire course. And once you master the pattern, everything else becomes much easier. Dimensional analysis, complicated word, but it's basically a structured way to convert from one unit to another. Instead of guessing or memorizing, we use fractions called conversion factors that allow units to cancel. This method works for metric units, English units, and even more complex chemistry problems later on in the course. A conversion factor is simply a fraction made from two quantities that are equal. For example, on this slide, you can see that 1 kilogram equals 2.20 pounds. If you divide both sides by either unit, you get a fraction equal to 1. That's why multiplying by a conversion factor doesn't change the value. It only changes the units. So basically, you have two numbers next to each other with an equal sign. You can write that another way with the values on top of each other, or the other way on top of each other. Okay? These fractions are sometimes called unity fractions because they equal 1. And when you multiply a value by 1, nothing changes. But the units change, and that's how we describe it. And this is the mathematical foundation of dimensional analysis. So I use something called the template pattern for every problem. You start with your given number and a unit that you're given, and then you multiply by a conversion factor, but you have to arrange it a certain way so that the starting units cancel. So please be sure to show the units, because the unit that's left over is your answer. Then you do the math on your calculator and you round it off using significant figures. I'll show you a couple of examples of this in action. So here's a question. It says convert 5.82 pounds to kilograms, and we're always given the information in the problem. It says use 1 kilograms equals 2.20 pounds. Okay, so step 1 is to write the equivalency as a conversion factor. Fancy word, just write the fraction, right? So you have the two equal signs. You're going to write two fractions one way or the other. So here they are. Okay, now we're going to proceed with the steps that I outlined on the previous slide. Step 1 is to write the starting quantity. So the starting quantity in the word problem is always the 5.82 pounds, right? Not the conversion factor, but some other number that's in the word problem. Okay. Step 2 is to multiply by a conversion factor, but remember, which one do you choose? You choose the one and you arrange the units so that they cancel appropriately. So you can see how the pounds here is on the left and the pounds here is on the bottom. Okay, so top and bottom are going to cancel. That's the way we want to arrange it. Okay, now you want to grab your calculator and do the math. Remember how when we were talking about significant figures, your calculator spits out a ton of numbers. So you want to count the number of significant figures in the 5.82. There's 3 there. And so you want the final answer to be rounded off to 3 significant figures. So we write 2.65. This is where we actually use the significant figures in calculations. Here's another example. We want to convert between quarts and liters. So the problem says convert 3.1 quarts, QT is the abbreviation for quarts, to liters. Okay, and we have some information here. 1 liter is equivalent to 1.06 quarts. Okay, so your first step is always to write out the conversion factors, especially if you're new and just starting out and this is very complicated. All right, so basically you write two different fractions one way or the other way. All right, and then you want to next decide which one of those is going to cancel out. So we have 3.1 quarts in the beginning, and we want quarts to be on the bottom in order to cancel out. Okay, so it's math where you have quarts on top of the fraction and quarts on bottom of the fraction, they're going to cancel out. Okay, so I'll show that with these little red lines here. Then you want to grab your calculator. You're going to take your calculator and you're going to type 3.1 and you're going to multiply by 1 because there's a 1 liter there. And then you're going to type divide with the divide key on your calculator and type 1.06, hit the equal, and you get 2.924, you know, like a whole bunch of numbers. Okay, we want to round this value off to 2 significant figures. Why 2? Because 3.1 has 2 sig figs. That's as precise as whatever measurement somebody did for that. So we want to write the final answer as 2.9. Make sure you put the liters. Okay, that's the final units of this problem. Unit cancellation is your built-in error check. If the units don't cancel diagonally, the conversion factor is upside down. So you need to fix the units first, then do the math. This is going to prevent almost every common mistake, but the trick is you have to write the units. Dimensional analysis is really important. This method is everywhere in chemistry. You'll use it for density, molar mass, gas laws, stoichiometry, just everything. Okay? So mastering the single-step conversions now sets you up for success later. So please practice, review, and carefully study this method. Thanks for watching.